Okay, you guys, so this is first part of using the titration to find your Ka value or your equilibrium constant. So what I have here is a weak acid. The unknown for this one is unknown A1. So there you want to write that down, unknown A1, up kind of by your name. I have about 0.2 grams of the A1, which I'm going to mix with 50 milliliters of distilled water in the beaker over here. Kind of behind the setup. This is the base that we're going to be using. This is the base from our previous lab. Concentration is about 0.09924 molar NaOH. But I already have that in the burette. I'll show you in a second. But I'm going to go ahead and pour this in here and mix my weak acid solid with the water into solution. And I'm going to turn on the magnetic stir bar here just a little bit to kind of mix that up. It takes a little bit to get these weak acids to dissolve in solution. Takes a minute or two, so I'll show you kind of what's going on here while we're waiting for that to dissolve. And I'll give you kind of a look at the setup a little closer here in a second. But yeah, so here's our setup. Sorry. Here is the burette. We're not going to have to write down our volume measurements here because we're going to use our pH probe to figure that out. We've got our pH probe there down at the bottom, or our LabQuest rather. Here's the pH probe here, and I'm going to take this and lower it down in the solution once we're ready to start the lab. But for right now, what I've got is that 0.2 grams of A1 in the solution, and I'm going to take out half of the solution. So it's a 50 milliliter solution right now. I'm going to go ahead and take out half of it. And so you want to go back and look at that little highlight video I did at the beginning about, equivalence points and so forth, and see if you understand kind of where we are. And there's questions, individual questions there in the Google form asking you to answer based on the information that I'm telling you now or you're witnessing. So that's 25 milliliters exactly. That was good. So I've got my 25 milliliters here. I'm going to set that off to the side. And I've got my 25 milliliters of my acid solution here, and I'm going to add just a little bit of phenolphthalein, 3-4 drops of phenolphthalein in there so that I can see where that equivalence point is going to be. And I'm going to lower my pH probe into the solution so we can measure the pH. Now, in order to do this, I've got to kind of wash the probe a little bit. I had it sitting in a buffer solution of pH of about 4. I'm going to lower this down into the solution so we can use it for the experiment. I don't want to have it hit the magnetic stir bar though. It's kind of important if you guys come back to school and you're doing these labs. You don't want to whack that pH probe, really thin glass membrane, with the magnetic stir bar. That would not be good. Okay, so we're at the beginning of the lab now. I'm going to move you a little bit closer so you can see what's going on here. A little bit too close. Let's see. That's pretty good about right there. All right. So here's our starting point. What I'm going to do is I'm going to go ahead and graph it. It's not going to be a perfect smooth graph like I showed you before, but it'll be okay. And so we're going to take readings. The readings are over here on the right-hand side. So we're at about 1.55 is our pH. And it's going to increase as I add the base to the solution. So I'm going to lower the burette down here. And I'm going to add kind of consistently until I get that pale pink color. So I'm just adding it kind of drop-wise there. You can see it dripping into solution. And it'll take a little while before it goes pink. But we're going to keep an eye on that pH as it's rising as I add more base to this weak acid solution. May turn it up just a hair. Just there we go. That's pretty good. We'll let that go like that just for a minute. And once we start to see that color change, I'm going to slow down and add drop-wise until I get a consistent pale pink color for about 15 seconds. That's the goal anyway. If it's longer than 15, it's fine, but you want it to kind of stay pink, not just turn pink and go away. That you're not at the equivalence point yet. You want that point where you have the same number of moles of base added as you had acid present in the solution. So we're getting to that color now. Okay, so now I'm going to go drop-wise. Just like a slow drip, drip. So here is 1, 2, 3. We're there. There we go. That's a nice, that is just barely pink. We could go one more, but I think I'll stop there. Okay, so we're going to say that that's our equivalence point. If we look at, oh, my pH probe, that's crazy. It's still going up. It's moving really slowly. Not sure if maybe it's because it's not immersed in the solution enough or not. Let's take a look. So we'll let that sit for a minute, let it level off. Let's add one more drop of phenolphthalein. Sorry guys, one more drop, make sure we're at that point. Boop, come on, boop. So we're there, but my probe is just really not giving me what I'm looking for. Let me see if I can turn the stir bar off and see if I can put this in a little bit deeper solution, like so. There we go. Let's see if we can get that. I don't think the probe is in enough solution to give me a good result here. About 6.64. So what I'm looking for, phenolphthalein generally changes color at about 8 to 9. And we saw the color change, and yet the pH probe is giving me a terrible reading here. I'm a little worried the probe may be bad. I'll let it go until it gets stabilized. Should have been a little easier than that. What are we at now? We're at 7.4647. Let's see, where are we now? 7.59. So what I'm going to do here in a second is I'm going to take the other half of the solution that I had originally. So this is going to be, we can get it to kind of stabilize. Still moving slowly. Seven 7.85. Should be close. Let's see where we are now. 7.98, 8.01. Maybe we do have to go the full 5 minutes or so. I'm not sure. That's just crazy. Should have been a little quicker than this. So at this point, it should be at the equivalence point, the point at which, you know, the moles of acid, moles of base are the same. What I'm going to do is I'm going to add in the other 25 milliliters to this. Let's get my pH probe set up. I'm going to turn my stir bar back on. And I'm going to go ahead and add the other 25 milliliters of acid. And so what I've done is I did find the equivalence point with 25 milliliters of acid, and now I've added 25 milliliters of acid back in there. What we should see happen, I'll just take the data again, is we're going to see that pH value go down. Let's go back and look here. So our pH value has now decreased from where it was at about 8 back down to 1.83. So think about what this point is, and then you're going to write what you think that point is in your data chart and answer the rest of the questions. And you'll have to choose which one of the weak acids you think this one is. Okay? Thanks.